Hey, we're showing up today to do a video on solving a linear system of equations. There's numerous ways to solve a linear system of equations. This video is going to show you how to do it using what we call linear combinations. Um, a linear system of equations is kind of like these two equations here. If you have those two equations graphed on a line, in order to solve those, you have to find out where those two lines are going to intersect, where those two lines are going to cross. And that's what we're going to show you how to do today. So um, just a quick vocabulary term up here, coefficients. Coefficients will be the number in front of the variable. If we look down here, 2 is a coefficient, -3 is a coefficient, 8 is not. There's no variable beside 8. 3 and -4 are also coefficients. So that's a quick definition here. There are numerous steps to solving a linear system of equations with linear combinations. So I have 3 slides here for you, and then I've kind of broken them down into 3 separate goals, and and each goal has a couple steps with it. But once you get used to doing this, you won't be thinking about this stuff. It'll just come naturally to you, and you'll automatically do it. The goal for this slide is to try and get the coefficients in front of one variable to be opposite of each other. And if we look, the coefficients in front of the x's are opposite of each other. One's a +2, the other one's a -2. If we look over here in the other set, the other system of equations, the y's have opposite numbers in front of them. One's -7, the other one's +7. And if we notice, the x's are different. And over here, the y's, the coefficients are different. So the whole goal is to try and get the coefficients in front of one of those variables to be opposite of each other. So there are 2 steps in doing that. First step, set up the like terms above and below each other. And if we look here, we have terms above and below each other, but one of them's a y and one of them's an x. And we don't want that to happen. We want to be able to set them up directly above each other. I'm going to look at the top equation. I see -4x on the right side, so I'm going to go ahead and add 4x to both sides of the equation. And so this one changes to 4x plus 3y is equal to a +16. And if we look at the bottom equation stays the same. 2x minus 3y is equal to 8. Now let's look at step number 2. If needed, you may not need to, but if needed, you're going to multiply one or both of the equations by a number to get the coefficients to be opposites. Let's look here. We already have opposites already. We have a +3 in front of the y and a -3 in front of the y. Step number 2 in this case is not needed, but we can look at, let's look here at the x's. You have a +4x on top. What could you multiply the bottom 2x by to make it a -4x? Well, you would multiply the bottom equation by -2x, because if, for instance, we're not going to do this on the next slide, but I just want to show you how this works out. If you multiply the bottom equation by -2, so -2 times 2x is a -4x, and -2 times -3y is a +6y. And then -2 times +8 is a -16. And you notice here how now we have a +4x and a negative 4x, and those are opposites of each other. Sometimes you'll have to do this, sometimes you won't. I just wanted to, while we were going over this step, I wanted to show you that. So, in this case, we're going to go ahead and we're going to allow those 3y and negative 3y to be the variable that we eliminate here on the next page. Rightio then. So that's where we're at. All right, let's go to the next page. Let's see what the next school is. The next school says we are supposed to solve for one of the variables. Solve for one of the variables. Well, how are we going to do this? Step number one, add the two equations together. In parentheses below that, it says the opposite coefficients should cancel each other out. Well, let's add these two equations together. Put a line under here and put a plus sign there. So let's add. What is 4x plus 2x? 6x. What is 3y plus negative 3y? That would be 0y. And 16 plus 8? 24. Now, the whole reason why we need opposite numbers in front of there is so we get a 0 right here. And we all know 0 times y is going to be 0. So 6x plus 0 is 6x. And so essentially when you do this on your own, you probably won't even write 0y there. You'll know that they just cancel out. Well, we're supposed to be solving for one of the variables. We've completed step one. Now let's look at step two. Solve for the variable that is left. What variable is left? That's x. Well, how do we get x by itself? Divide by 6, divide by 6. Cancels out. So x is equal to 24 divided by 6 is 4. You got it. X is equal to 4. Let's look at the next page. Our next goal here, since x is equal to 4, our next goal is to solve for the other variable. And in this case, it's going to be y. It won't always be y. Sometimes you solve for y first, and then you solve for x on this goal. But this one, we're solving for y. How do you do that? Substitute. You're going to plug in the value. You're going to substitute the value for the variable that you just found. In our case, it's x. And you're going to plug it into one of the equations. You can plug it into both of the equations. You should still get the same value for y if you kind of want to check to make sure you're correct. But there are other ways to check your solution to make sure it's correct. And we're going to find the value of the other variable. That's the last step here. Well, let's look right here. X is equal to 4. I picked one of the equations we started with. I believe that was the first one we started with. And I took, for x equal to 4, and I plugged it right in there for x. And you can see that right here. I plugged it in there for x, substituted it in. And so from here, this is just solving for y. So let's work this out. Negative 4 times 4, negative 16. We add 16, and on the left side, that's equal to 3y. Negative 16 plus negative 16 will give us a 0. So now we have 3y is equal to 0. Divide by 3, divide by 3, cross it off. So now y is equal to 0. Y is equal to 0. You're finished with this problem, and your final answer is going to be an ordered pair, like a point on the graph on the coordinate plane. The x value is 4. Y value is 0. So those two equations that we started out with should cross at 4, 0. Let me bring up the other equation here and show you that it doesn't matter which equation. You have to plug it into one of the equations. Plug x into one of the equations to solve for y. but it doesn't matter which one, and I'm just doing this just to show you that it doesn't matter which one. So here's x, so we plug 4 in for x and solve this out. 2 times 4, 8, minus 3y, and that's equal to 8. And this 8 over here on the left side of -3, he's not real good friends with the -3, so he says, I'm packing up my bags, I'm moving on over to the other side of the street. Comes over and he says, howdy do to the +8. So 8 and -8 hang out together, and they make nothing. Well, that's no good. They should be a little more productive than that. They should make something. Well, they don't. So that's how it is when you're opposites. You combine to get nothing. So let's look here. -3y is equal to 0. Divide both sides by -3. So y is equal to 0 divided by -3? 0. And if we look, x is 4, y is 0, and that's the same numbers we got before. So it's one way to do it. We can look. Let me bring up a graph here real quick, a graph of those two equations. And do those two equations cross at 4, 0? Yeah, they do, because if you start at the origin, you can go to the right 1, 2, 3, 4, and up and down 0, 4, 0. And that's where those two lines are intersecting, and that's where those two equations from our system of linear equations will be crossing. So now we're back here. Well, let's see if we can solve a few of these on our own. If you look, I have kind of 6 steps up there, kind of just hints or reminders for you. They don't exactly outline everything I outlined in the last 3 slides, but they're kind of reminders for you. Step number 1 says line up like terms, and we already have that done. We have the x's lined up, we have the y's lined up, and we have the numbers without variables lined up. Step number 2 says multiply the equations, and that's going to be if needed. If needed. Well, why would we line those up and multiply them? The whole goal, remember, is to try and get the numbers in front of the variables, the coefficients, trying to get the coefficients to be opposite of each other. Well, if we look here, that's a 1 and that's a -3. They're not going to be opposite of each other. If we look in front of the y's, let me put down my eraser here. Look in front of the y's, that's a -1 and that's a -1. Okay, so they're the same number, that's good, but they're not opposite of each other. So we have to make them opposite of each other, and so in order to do that, we have to multiply one equation by -1. I'm going to multiply the top equation by -1 because I like multiplying things by 0. It's real simple. I'm going to draw a little arrow over here because I'm going to put my work over here. -1 times x will give us a -x. -1 times a -y gives us a positive y. It's my favorite part. It's my favorite part of the show. -1 times 0. What is it? What is it? Yes, you got it. 0. Man, that was pretty tough. That's why it's my favorite part. On the bottom, looky, looky, looky. And this one here doesn't change because right here is why it doesn't change. The y's are going to be opposite of each other now. So we just rewrite that one. Nothing changes there. All right, now since we have opposite coefficients in front of the y, step number 3, add the equations. So let's add the equations. -x plus -3x. Well, they both have negative signs, so it's going to be a -4x. Add those together. Add those numbers together and keep the sign of the larger number. Wow. Let me try that again. You will add the numbers together and then keep the sign of the number that has the larger absolute value, which is negative. Uh, Positive 1y plus negative 1y will leave us with 0y, so we're not going to write anything there because 0y is 0. And this is equal to 0 plus 2 is a 2. How we go get x by itself? You got it. Divided by negative 4. Negative 4 divided by negative 4 crosses off. X is equal to 2 over negative 4. We know 2 and 4 reduce to become 1/2. And a positive divided by a negative will leave us with a negative. So, that is where we're at. So, that was step 3. Nope, that was step 3 and 4. I completely skipped over saying step 4. Step 4 said solve for the variable, which we did that. Man, we got on a roll there and couldn't stop. Oh, like a snowball effect. You couldn't stop the snowball. Oh, step number 5 now. Let's look at that. Substitute and solve for the other variable. Well, we know x is negative 1/2. So we put negative 1/2 right here. Now we have to find the y value. We have to find that y value. So which equation do you want to use, top or bottom? I think the top one's going to be a little bit easier to use. We can use the bottom one if you really want to. No? Okay, that's fine. We'll use the top one then. All right, so the top equation says x minus y is equal to 0. What's x equal to? Negative 1/2. So we say negative 1/2 minus y is equal to 0. Now, how do you solve for y? A lot of you might be inclined to say that we should add 1/2, but then if we do that, we still have the negative sign in front of the y, so then we're going to have to either divide both sides by negative 1 or multiply both sides by negative 1, depending on how you think about it. But looking here, why don't we just add y to both sides? We can do that. That is completely legal to do. As long as we add y to the left side and we add y to the right side, we have a still balanced equation. So on the right side, what is, well, those canceled out. What is 0 plus y on the right side? 0 plus y is going to give us a positive y. And so from here, we should be able to figure out that y is equal to negative 1/2. Since y is equal to negative 1/2, we write negative 1/2 right there. Still snowballing here, right in an ordered pair. That is your final answer right there. The two equations that we start out with, this system of equations right here, is going to cross, is going to intersect at that point right there. Negative 1/2, negative 1/2. Here's another problem. Solve the system of linear equations. We're doing this by linear combinations. This problem would be probably a little bit easier to solve if you were using substitution. You would just substitute x minus 9 in there for y. In the bottom equation, right here, you would write x minus 9 and then solve it out. But since this video is on linear combinations, we're not going to be doing any solving systems by substitution. All right, so let's look here. Step number 1, line up the variables. Well, we have x and 8y on the left side, and up here on top, we only have y on the left side of the equal sign. So we have to move some things here, which is probably going to be moving this x. In order to move this positive x on the top, in order to move that x, we have to subtract x from both sides. And so now we have negative x positive y and negative 9. On the bottom, we have x plus 8y is equal to 0. That bottom equation, we didn't have to change anything to it. And now if we look, we have like terms lined up. Step number 2 is if needed. It says multiply the equations. What's the whole goal? What are we trying to get right here? Think about it. What's the whole goal that we're trying to get? We're trying to get the coefficients to be opposite of each other. And if we look, are the coefficients opposite of each other? They are. They are. It's in front of the y is a 1y. That's not opposite of 8, but in front of the x's, those are the ones that are going to be opposite of each other. We have a negative 1x in front of x and a positive 1x in front of x. So we're good to go there. Good to go. Okie dokie. Step 3, add the equations. I wasn't near step 3. Step 3, add the equations. Let me, ooh, look at that, yellow. We haven't used yellow today. And it's on a yellow problem. Oh my, that is neato right there. Rightio. Neato, rightio. Hey, it's kind of neat. Things ending in O. Negative x plus x cancels out for 0x. 1y plus 8y gives you a 9y. And on the right side, negative 9 plus 0 is negative 9. So this is where we're at. Step 4. Hey, no snowballing going on in this problem. Step number 4, we are solving for y, so we divide by 9. Divide by 9. The y's cancel out. Or not the y's, the 9's cancel out. Y is equal to negative 9 divided by positive 9. Well, we know 9 divided by 9 is going to be 1, and it's a negative 1, because a negative divided by a positive is a negative. We're going to get a jump start here on step 6. Since y is equal to negative 1, we're going to write it on the right side, because that's where the y value is. Okay. Let's do step 5. Substitute and solve for the other variable. Well, we know what y is. I need to substitute y and solve for x. So which equation are you wanting to use? Top or bottom? You can plug it into the bottom and solve it out for x, or you can plug it into the top and solve it out for x. I think the bottom one might be a little bit easier. We substituted right here for y. Maybe I could go ahead and draw that. Substituted right there for y. And now we know x and 8 times negative 1 will give us a negative 8. And how are you going to get x by itself? Yep. X and 8 aren't getting along again. So 8's going across the road. Hang out with 0. So x is equal to 0 plus 8, which is 8. There you go. So since x is equal to 8, we write that into our ordered pair, which completes step number 6 for us. So we know that these two equations, this system of equations, is going to intersect, is going to cross at that point right there, 8, negative 1. All right, solve the system of linear equations. This one doesn't have x and y in it. Sometimes we work with things that do not have x and y. They have other variables. But when we write our ordered pair here, typically you always put the letters in alphabetic order. Now, if you're doing a word problem or some sort of real-life situation, that might not always be true. Sometimes they might be, backwards. But if we're going to be doing problems that just say solve the system of equations like this, we will we will have to, we're going to put them in alphabetical order here. So in this case, whatever we find for A will go in the first spot, and whatever we find for Z will go in the second spot. Step one, let's go ahead and get this solved here. Step one says line up the like terms. Like terms are already lined up. Boy, that's rocking right there. We like it when things are already done for us. All right, step number two says multiply the equations. Remember, you can multiply one equation or both equations, or sometimes you don't even have to multiply any equations at all, because the whole goal is to get the coefficients to be opposite of each other, and there only has to be one of them, either the ones in front of the A or the ones in front of the Z. And so, now look here. Look here. Is there a number? Let's look at this A right here. Is there a number that I can multiply 2 by to get 3? Well, yeah, we can. We can multiply it by 1.5, or we can multiply it by 3 halves. Probably not going to really be a whole lot of fun for us to be working with fractions. There's a little bit easier way than working with fractions here. Let's look here at the 6z. I'm always looking at the smaller number to see if I can multiply it by something to get the larger coefficient. So is there something I can multiply 6 by to get -7? Or actually, we need them to be opposite, and they are already opposite, which is good, but we need them to be the same number. And there is no number that I can easily multiply 6 by to get 7 and still do this problem fairly quickly. So if we cannot do that, then that means we cannot multiply just one of those equations to solve it. We have to multiply both of those equations by a number. So a couple things here. There's 2 different ways we can do it, and I'm probably always going to multiply by the smaller numbers. I like working with the smaller numbers better, but I will go ahead and show you right now how we can, since that's positive and negative, that's a good start. So what is going to be the least common multiple here of 6 and 7? Well, if we make multiples of 6, I mean, we keep going out here. This is why it's real helpful to know your multiplication tables here. Multiples of 7, and if you know your multiplication tables, you don't really have to ever do this. If you don't know your multiplication tables, or you have to do this, or maybe you just get a multiplication chart and look at that. Maybe that can help you out, but it's real helpful to know your multiplication tables, because then you don't have to do things like this. So do they have any numbers in common? They have a 42 in common. 42 in common. So what do you have to multiply the 7 by to get 42? The 7 has to get multiplied by 6, and what do you have to multiply the 6 by to get 42? The 6 gets multiplied by 7. In this case, you have to multiply it by each other, but you won't always do that. I have another example to show you of that, of how you won't always do that. Okay, let me show you something here. So we said we had to multiply the 6 by 7 to get 42. And we said we had to multiply the 7 by 6 to get 42. So multiply both of these equations. So let's go ahead and do that. 7 times 2a, 14a. 7 times a positive 6z is a positive 42z. And 7 times 4 is going to be 28. On the bottom, 6 times 3a, 18a. 6 times negative 7z is negative 42z. And 6 times 6, 36. So what do you think? Some pretty large numbers there. If you like working with large numbers, You can go ahead and do it that way. Let me show you the way that I would have preferred to do it. Let's use this color. I know 2 and 3 will have a common multiple of 6. So what do you have to multiply 2 by to get 6? In this case, it's 3. What do you have to multiply 3 by to get 6? In this case, it'll be 2. So if we think about this, remember they're supposed to be opposite of each other, and the positive and negative sign go with 6 and 7. So the 2 is positive, the 3 is positive. Well, we have to make them opposite of each other, so how can we make them opposite? We just put a negative sign with one of those numbers, and it doesn't matter whether it goes with the 2 or the 3. So let's multiply these. 3 times 2a, 6a. 3 times 6z is positive 18z. And 3 times 4 is 12. On the bottom, negative 2 times 3a is negative 6a. Negative 2 times negative 7 is 14z, and that's a positive 14z. Negative times a negative becomes a positive. And negative 2 times 6 is negative 12. Which numbers do you like working with? These numbers which are smaller, or these numbers which are larger? I like working with the smaller numbers, so from here on out we're probably going to just be using smaller numbers to do this. But I'm showing you either way you could have solved it out. Let me get rid of these large numbers here. They're starting to scare me a little bit, sitting up here in the corner staring at me. Yeah, that's much better. Yeah, okay. All right, step 2. Step 2, we have step 2 done. It says multiply one or both of the equations, or if needed, or we could have multiplied none if needed. That's what that if needed meant. Add the equations. Hey, we're there. We can add equations. Let's bring back yellow. There we go. 6a plus negative 6a cancels out. 18z plus 14z. 18 plus 14, well, we know 8 plus 4 is 12. Carry your 1. 1 plus 1 plus 1 is 3. 18 plus 14 is 32. 32z. 12 plus negative 12 is 0. Equations added. Step 4. Solve for the variable. I think we divide by 32. Z is equal to 0 over 32 is 0. So let's go ahead and write that into our ordered pair. Z is equal to 0. Now, step 5, substitute and solve for the other variable. Let's just take this top equation here. This top equation. 2a plus 6 times z, what do we find z to be? 0 is equal to 4. And solve this for a. What's 6 times 0? 0. 2a plus 0 is just 2a. So now we have 2a is equal to 4. And how are you going to get a by itself? Cancel out the 2 in front of a. A is equal to 4 divided by 2. It's 2. Oh, we haven't done step number 6. Write in an ordered pair. A is 2. So, if we look at these two equations, that system of equations intersects at 2, 0. Okay, I got a problem here. I want you to go ahead and try that. See if you can go through all 6 steps to solve that out. When you get finished, unpause the video and check your solution. I'm going to work through that now. All right, so first step, line up like terms. They are kind of lined up, right? You got to make sure you pay attention. We have 3x and 6z on the left side of the equal sign. On the left side of this equal sign, we only have 9x. So we got to make sure we put those together. We got to make sure we get that 3z over there somehow. And how do we do that? Well, if we need to move that 3z, we can subtract 3z. And we subtract 3z. So since x is first here, when I rewrite this, I'm going to, when I rewrite it down here, I'm going to put 9x first. We subtracted 3z from both sides. And on the right side, since those 3z's canceled out, we're still left with 20. Go ahead and bring down that second equation. Bring down this equation here. 3x plus 6z is equal to 2. And what's the next step? We have them lined up. Next step is to multiply the equations. I know if I multiply that smaller number, that smaller coefficient of 3 by a 3, I'll get 9. So therefore, I could multiply it by negative 3 and get negative 9. And then those would be opposites. I also know if I multiply this smaller coefficient of negative 3 by 2, I'm going to get the opposite of that larger coefficient of 6. And I would just multiply that by a positive 2, so I wouldn't have to worry about dealing with negative signs. So that's what I'm going to do. I'm going to multiply that top equation by 2. And bring that over. 2 times 9x, 18x. 2 times negative 3z is negative 6z. And 2 times 20 is 40. This bottom equation stays the same. So this is where we're at. Multiply the equations is done. Step number 3, add the equations. So we can go ahead and add the equations. Bringing back yellow. Here we go. Add the equations. 18x plus 3x is 21x. There you go. Negative 6z plus positive 6z is a 0z. And 40 plus 2, 42. That would be what you have. Step number 4 over here says solve for the variable. Well, let's solve for that variable by dividing both sides by 21. So x is equal to 2. 2, 2. X is equal to 2, 2. Kind of sounds like Tutu or Toto, like the little dog from All from the Wicked Witch. So x is equal to, let's get back on track here. X is equal to 2. X, and the other variable was z. So if we put those in alphabetical order, x will come first, z will come second. X is equal to 2, so we write that into the ordered pair. Now we're on to step number 5. Substitute and solve. Substitute and solve for the other variable. We need to solve for y, or I'm sorry, z. It doesn't matter which one we solve for, either the top equation or the bottom equation. I'm choosing the bottom. Looks like it just has smaller numbers. Since x is equal to 2, we're going to substitute 2 in there. 3 times 2 is 6. And we have to get z by itself, so we're going to subtract 6. Those cancel. We're left with a positive 6z, and 2 minus 6 is negative 4. Divide each side by 6. So z is equal to, this reduces to a negative 2/3. 2 goes into both of those numbers. 2 goes into 4 twice, and 2 goes into 6 3 times. So these two equations, those two equations will cross right there. that ordered pair. That system of linear equations is now solved. And let's look here. We have another system of linear equations. This one's using P and Q. Do you remember which letter comes first? M, N, O, P, Q. So your ordered pair should look like that. PQ. I want you to go ahead and try and solve this one using linear combinations. And when you get this solved, unpause the video and see what you can see if your solution matches up with mine, and check your work. Go ahead and pause the video now. Step number 1 says line up the equations. I'm looking. Well, I know Q is on one side of the equal sign all by itself here, and Q is on the other side of the equal sign all by itself there. What can we do? Well, let's take and rewrite this equation. Since P is first, I'm going to take that negative 5P, and I'm going to write it first. Negative 5P. 7 right here is positive, so we put plus 7 is equal to, and positive 2Q. All right, well, let me erase some of this, and now you can solve a system of linear equations like this. Just because both variables aren't on the same side, it's still possible to solve it like this if you want to. What's going to be easier numbers to work with? 4 is positive, 5 is negative, which is good, so we're going to have to, least common multiple of 4 and 5 is 20. Let's look at the 1 here is positive, the 2 is positive, so we're just going to multiply. If we want to eliminate the coefficients in front of Q, we have to multiply one equation by a negative number. Not that hard. But this is the invisible one, so what's the least common multiple of 1 and 2? That would be 2. So I like that smaller number there, so that's the one we're going to go with. So let's see, what do we have here? Remember, we're not working with that top equation anymore. So we just have to multiply this equation here now by a 2 to get it to match up with that 2, and they have to be opposites. So let's go ahead and multiply the top one by negative 2 while we're multiplying that. So negative 2 times 4p will give us a negative 8p. Negative 2 times negative 16 is a positive 32. And negative 2 times 1q is negative 2q. This equation will stay the same. Negative 5p. Where are we at? Plus 7 and 2q. So that's where we're at. We kind of multiplied the equations if we needed to, and we needed to in that case. Next step says add the equations. Here's the two equations we have to be adding. Let's go ahead and add them. Negative 8p plus negative 5p. They're both negatives, so when we add them together, we're going to get a negative 32 plus 7 is 39, and negative 2q plus 2q, those cancel, and a lot of times you guys want to leave that blank, but remember there still has to be a number over there on the right side of the equal sign, and that number would be 0. So let's go ahead and try and get p by itself. You could subtract 39, or you could add 13p to both sides. I add 13p so I can get rid of that negative sign. And now how do we get p by itself? We're divided by 13. P is equal to 39 divided by 3, or I'm sorry, 39 divided by 13 is 3. 39 divided by 13 is 3. Solve for the variable. We've done that. Let's go ahead and get a jump start here. Remember, P come before Q, so we're going to put 3. We solve for P. It goes into the first spot. Okie dokie. Step number 5. Substitute and solve for the other variable. Oh, looky there. There's some green. We got some green now. Substitute and solve for the other variable. Let me erase some of this so we can actually see those two original equations. If we know P and we're trying to solve for Q, I'm going to put it into this equation here because we have Q all by itself there. Up here, we would have to divide by 2 to get Q by itself. So 4 times P, in our case, we already know it's 3. 4 times P minus 16 is equal to Q. 4 times 3 is 12 minus 16. That's equal to Q. And 12 minus 16 is a negative 4. So negative 4 is Q. So these two systems of linear equations intersect at 3, negative 4. That is the solution of the system of linear equations. Well, I think that's a good start for linear combinations to solve a system of linear equations. That's a good start for you. Try and do some practice. I think I'm going to be posting another video of some problems that are just some problems for you to work through. So be looking for that to come up onto the World Wide Web there, the internet space, and then once that comes up, you can go there and get you some practice on this. But I appreciate you stopping by today, checking out the video, and I will see you guys next time.